Right now, far beyond the orbit of Mars, something is racing away from our sun. It is a comet called 3I Atlas, and it does not belong to our solar system. It was born around another star. It crossed the empty dark between suns for longer than you can imagine. And this past winter, it swung past our sun, turned, and began the long journey back out. As it left, the most powerful telescope ever built was watching. The James Webb Space Telescope read its chemistry, molecule by molecule. And what that chemistry revealed stunned the scientists who study it. Because the numbers point to something almost impossible. This comet may be older than the sun, older than the Earth, older than the entire solar system you're standing in. In the next half hour, I'm going to show you exactly what Webb found. I'm going to show you the single measurement that hints at 12 billion years of age. And I'm going to explain why one Harvard scientist still refuses to call it a comet at all. Let us start with what this object actually is, because it is genuinely rare. Astronomers have only ever confirmed 3 visitors from beyond our solar system, just 3 in all of recorded history, and 3I Atlas is the third. It was first spotted on the 1st of July, 2025. The discovery came from a NASA-funded survey telescope in Rio Hurtado in Chile. At first, it looked like an ordinary comet, a faint smudge of light drifting against the stars. But its motion was wrong. It was moving too fast, far too fast for anything bound to our sun. And its path was not a loop. It was a straight shot through on a curve that only leads back out to the stars. That was the tell. This object was never ours. It was passing through, a traveler from another star system caught for a few brief months in our sun's light. NASA gave it the name 3I Atlas. The letter I stands for interstellar. The 3 means it is only the third we have ever caught. Its full name marks it in the record books forever as the third of its kind. Before it earned that name, it carried a temporary string of code, the kind given to every new object. Within days, its true nature became clear. The survey that found it, called Atlas, exists to hunt for asteroids that might one day threaten Earth. It scans the whole sky night after night, looking for anything that moves. And to understand why that matters, you have to meet the 2 that came before it. The first arrived in 2017. Astronomers named it Oumuamua, a Hawaiian word meaning a scout or a messenger sent from far away. Oumuamua was strange from the very start. It was long and thin, tumbling end over end. It gave off no visible tail of gas or dust. And as it left, it sped up slightly in a way that gravity alone could not explain. That tiny push started years of argument that has never fully ended. For Oumuamua, scientists could not even agree on its shape. Some argued it was long, like a cigar. Others thought it looked more like a flat spinning disk. Oumuamua also passed by quickly and faded before anyone could study it closely. It was gone within weeks, leaving mostly questions behind. To this day, no one knows for certain what Oumuamua truly was. It left more mystery than answers, and that shadow still hangs over every new visitor. The second visitor came in 2019. It was called 2I Borisov, after the amateur astronomer who found it. Borisov was different. It looked and behaved like a normal comet, with a clear tail and familiar chemistry. It was reassuring. In a way, it looked like home. Borisov was watched for months. Late in its passage, it even flung off a chunk of itself and briefly brightened, a very comet-like thing to do. Both earlier visitors shared one thing with this new one. Their speed and their paths proved they had come from far beyond our sun. So, by the time 3I Atlas appeared, scientists had seen 2 very different kinds of interstellar visitor. One that puzzled everyone, one that felt ordinary. The question was simple. Which kind would this third one turn out to be? To answer that, they needed a closer look than any ground telescope could give. They needed Webb. Before we get to Webb, let me show you how we know this comet is truly a stranger. Everything that orbits our sun follows a closed path. Planets, asteroids, ordinary comets. They loop around, again and again, held by gravity like a stone on a string. 3I Atlas is not on a closed path. It is moving so fast that the sun can never hold on to it. Its speed relative to the sun was tens of kilometers every single second. That is more than the sun's gravity could ever tame. Astronomers describe its route as hyperbolic. In plain terms, that means it comes in from deep space, bends around the sun once, and leaves for deep space again. It will never come back. Not in 1,000 years. Not in 1,000,000. This is a one-time passage, and then it is gone. To picture it, imagine throwing a ball so hard that it never falls back down. That is what 3I Atlas is doing with our entire sun. Its closest approach to the sun is called perihelion. That is the moment a comet gets hottest and most active. 3I Atlas reached its perihelion in late 2025. The sun's heat poured into it. Its buried ices began to boil away into space. And that heating is exactly what made the next discovery possible, because as the comet warmed, it started to breathe out its secrets. In December of 2025, the James Webb Space Telescope locked onto the comet. By then, 3I Atlas had rounded the sun and was heading back out toward deep space. Webb watched it carefully as it moved away. Webb does not see the way your eyes do. It sees in infrared, the light of heat, and that lets it read the chemistry of a distant object directly. It used two instruments. One is called NIRSPEC, the near-infrared spectrograph. The other is called MIRI, the mid-infrared instrument. Here's how they work. Every molecule absorbs and emits light at its own exact colors. A spectrograph spreads that light out, like a prism spreading sunlight into a rainbow. In that rainbow, each gas leaves a dark or bright line, a fingerprint. Read the fingerprints, and you know exactly what a comet is made of. Reading an interstellar comet this way is extraordinarily hard. The object is small, faint, and moving fast against a field of stars. When Webb first turned toward the comet, astronomers described it as unlike anything they had seen in our own solar system. Around its solid core sat a coma, a vast cloud of gas and dust released by the warming ice. That cloud is what Webb's instruments actually read. No one had ever done this in full for an interstellar comet before. Webb captured the first complete chemical fingerprint of a visitor from another star. And almost immediately, one line in that fingerprint made no sense. The surprise was a gas called methane. Methane is a simple molecule, 1 carbon and 4 hydrogen atoms. On Earth, it is natural gas. In space, it is a delicate, easily lost ice. For the first time ever, Webb directly detected methane on an interstellar visitor. That alone was a milestone worth pausing on. But the way it appeared is what puzzled the team. Methane melts and escapes at very low temperatures. So a comet that flies near a star usually loses its methane early. In the cold of deep space, methane can freeze onto a comet and stay locked in place. But it is one of the very first ices to escape once a comet warms up. By all rights, 3I Atlas should have been stripped of its methane long before Webb looked. Instead, the methane showed up late, after the comet had already rounded the sun. NASA scientists say that delay is the key clue. The methane was not sitting on the surface. It was buried deep inside the comet's body. It stayed locked away, shielded from the sun until the heat of perihelion finally reached down into the deeper ice and set it free. Think about what that means. This gas had been sealed in the dark for billions of years, and Webb caught the exact moment it escaped. There was more. The amount of methane was strangely high. By one measure, the methane compared to water was around 11 times higher than any object ever measured in our solar system. So the team kept reading the fingerprint, and the rest of the chemistry was just as alien. Most comets in our solar system are, at heart, dirty snowballs. Their main ingredient is water ice. 3I Atlas broke that rule. Webb found it was unusually rich in carbon dioxide, the same gas you breathe out. It was releasing far more carbon dioxide relative to water than a typical local comet ever would. That is a red flag for a very different birthplace. In our neighborhood, comets are mostly water. Carbon dioxide is usually a minor player. Here, that order was flipped on its head. The full list of ingredients read like nothing familiar. There was water ice and water vapor. There was carbon monoxide. There was carbon dioxide and methane. And there was one more, with a name most people never hear. Carbonyl sulfide, a molecule built from carbon, oxygen, and sulfur. That sulfur-bearing ice is a special prize. Sulfur chemistry is closely tied to the raw ingredients that living things are built from. Each of these ices freezes and escapes at a different temperature. Together, they act like a thermometer, recording the cold of the place where the comet was born. And the reading on that thermometer was extreme. Webb data showed a mixture that only makes sense if this comet formed somewhere brutally, impossibly cold. Colder than the edge of our own solar system. Colder, perhaps, than almost anywhere that planets are usually born. But the single most important clue was not any one of these gases. It was hidden inside the water itself. To understand it, you need one small fact about water. Water is made of hydrogen and oxygen. But hydrogen comes in two forms. There is ordinary, light hydrogen, and there is a heavier version called deuterium. Deuterium is just hydrogen with a little extra weight in its core. And here's the useful part. Colder conditions lock more deuterium into water ice. So the ratio of heavy hydrogen to light hydrogen in a comet's water is a record. It tells you how cold things were when that water first froze. Webb's NIRSPEC measured that ratio in 3I Atlas. And the results stopped the researchers cold. The comet's water held about 30 times more deuterium than the comets of our own solar system. 30 times over. Put as a plain number, the measured level was about 0.98%. In our solar system's comets, it sits many times lower than that. That is not a small difference. It is more than an order of magnitude beyond anything we see at home. The team then calculated what temperature could produce it. The answer was around 30 Kelvin. That is roughly minus 243 degrees Celsius. That is only about 30 degrees above the coldest temperature that is physically possible. This comet's water froze in a place close to absolute zero, and that deep, deep cold pointed the researchers toward an age no one had expected. The second great clue was carbon. Carbon, like hydrogen, comes in more than one form. There is common carbon-12, and there is a rarer, heavier version called carbon-13. Here is why that matters across cosmic time. When the universe was young, it held very little carbon-13. Heavier carbon is built up slowly inside generations of stars. Stars live, forge new elements, and then die. Each cycle seeds the galaxy with a little more carbon-13. So the ratio of these two carbons acts like a clock. An object with very little carbon-13 was likely made when the galaxy itself was still young. Astronomers even have a rough map of how this enrichment climbed over the history of the Milky Way. The less carbon-13 you find in general, the further back in time you are looking. Webb measured that ratio in the comet's carbon dioxide and in its carbon monoxide. And 3I Atlas was strikingly poor in carbon-13. In hard numbers, the team counted well over 100 atoms of ordinary carbon for every single atom of carbon-13. That is far more lopsided than comets from home. It carried the chemical signature of an early, unpolished galaxy. A galaxy that had not yet lived through billions of years of star death. Put the two clues together. Water frozen near absolute zero. Carbon from a young galaxy. Both point in the same direction. Both point backward into the deep past. And when the team ran the numbers, that past turned out to be staggering. Here's the conclusion that made headlines around the world. The research team estimates that 3I Atlas formed between 10 and 12 billion years ago. Let those numbers settle for a second. Our sun is about 4.5 billion years old. The Earth beneath your feet is about the same. This comet may be nearly 3 times older than both of them. It likely formed during an era astronomers call cosmic noon. That was roughly 10 billion years ago when galaxies across the universe were forming stars at their fastest rate. At that time, there was no sun. There was no Earth. There was no solar system at all. Just gas, dust, and a young, blazing galaxy. And in some frozen corner of it, this comet quietly came together. And then it waited. It waited while our sun ignited. It waited while the planets formed. It waited while life crawled out of Earth's oceans and eventually looked up at the sky. The findings were published in the journal Nature in June of 2026, with related work in the astrophysical journal Letters. The lead researcher, Martin Cordner of NASA, put it simply, "This comet gives us direct insight into a distant time and place we could never otherwise reach. Stars this ancient belong to the oldest population in our galaxy. If the estimate holds, this comet was forged alongside some of the first generations of stars." Cordner and his colleagues note that studying it also teaches us something humbling. It hints at just how unusual our own solar system may be. It is, quite possibly, the oldest object humanity has ever directly observed. A relic that predates everything we call home, but not everyone reads the evidence the very same way. Now I want to be careful and fair here. What follows is a minority view. Most astronomers do not accept it, but it is worth understanding. The scientist behind it is Avi Loeb, a physicist at Harvard University. Loeb has spent years arguing that we should take one possibility seriously, the possibility that some interstellar visitors could be technology, not just rock and ice. He is not saying he has proof. He is saying we should not rule it out before we look. And for 3I Atlas, he has assembled a long list of what he calls anomalies. Over the comet's passage, Loeb cataloged more than 20 separate features that he considers unusual. Most scientists explain each one as ordinary comet behavior. Loeb argues that the comet has shown non-gravitational acceleration. That means it sped up or shifted in ways that gravity alone does not explain. Now, for a normal comet, that is fully expected. Escaping gas acts like a small engine and nudges the comet along. But Loeb argues the push here was large, while the comet appeared to stay whole and did not visibly break apart. He also points to jets, tightly focused streams of material that, he says, held a steady direction across enormous distances. And then there is the coincidence that fascinates him most. On the 16th of March, 2026, 3I Atlas makes a close pass by the planet Jupiter. Loeb calculated that its closest distance to Jupiter lands almost exactly on Jupiter's Hill radius. That is the invisible boundary of Jupiter's gravitational domain. By his math, the odds of that alignment happening purely by chance are tiny, roughly 4 in 100,000. He also points to special parking spots near Jupiter, called Lagrange points, where an object needs almost no fuel to stay in place. Loeb speculates that such a spot would be the ideal place for craft to release small satellites around Jupiter, using the least possible fuel. Loeb has also written about a jet that seemed to point back toward the sun, and about a deflection of roughly 16 degrees as the comet swung around perihelion. Again, the mainstream reads these features as natural. Comets vent unevenly, and that uneven venting can twist their paths in complicated ways. To be absolutely clear, that is speculation, and Loeb presents it as speculation. He is describing what he cannot yet rule out, not what he has shown to be true. So what does the rest of the scientific community say to all of this? The answer from NASA is steady and clear. All the evidence says this is a comet. Tom Statler, a lead scientist for small bodies at NASA, has spoken for the mainstream view. Their position is straightforward. The color of 3I Atlas is comet-like. Its speed is comet-like. Its direction and its behavior are comet-like. It grows a coma, the fuzzy cloud of gas and dust around its core. It grows tails. It brightens and fades exactly as a comet should. And the strange chemistry, they argue, is not a sign of technology. It is a sign of a comet born around a different, older star. The non-gravitational push, NASA says, is the ordinary rocket effect of ices turning to gas. Every active comet feels it. In their reading, 3I Atlas is not less natural for being strange. It is more precious. It is a genuine comet from another world. NASA took it seriously enough to organize a huge campaign. More than 20 missions across the solar system were pointed toward this single visitor. Spacecraft near Mars joined the watch as the comet swept through the inner solar system. Telescopes on Earth tracked it night after night. NASA also stresses a simple point about the timeline. When the comet was first found, it was already active and behaving like a comet months before it neared the sun. That is not how you treat a threat. That is how you treat a once-in-history scientific gift. Still, even the mainstream admits one thing. This comet kept doing things they did not fully predict. Which brings us back to that final look, as the comet raced away from the sun. NASA has said plainly that what Webb saw, as 3I Atlas departed, surprised the researchers. The late burst of methane was part of it. So was the sheer strangeness of the chemistry, unlike almost anything we have at home. The comet did not simply fade quietly. It kept releasing gas, kept shifting, and kept behaving in ways that demanded new explanations. And now it is leaving for good. It rounded our sun once, and now it is climbing back out toward the stars, never to return. Ahead of it lies that close pass by Jupiter in March of 2026. After that, it fades into the dark, carrying its secrets with it. We will most likely never touch it. No spacecraft is positioned to chase it down and land. This brief study by Webb may be nearly all we ever learn. But think about what that brief study gave us. For a few short months, a piece of a 12-billion-year-old world passed right through our neighborhood. And we were ready. We had built a telescope powerful enough to read its story before it slipped away. Every reading Webb took is now open for scientists around the world to study. The data will be picked over carefully for years to come. One co-author, Stephanie Meelam of NASA, framed the deeper point. Studying these visitors helps us learn how common the conditions for life might be across the galaxy. So here is where we stand. A comet from another star passed through our solar system. The James Webb Space Telescope read its chemistry as it left. That chemistry pointed to water frozen near absolute zero and carbon from a young galaxy. Together, they suggest an age of up to 12 billion years. If that holds, 3I Atlas is older than the sun, older than the Earth, older than everything around you right now. Most scientists, led by NASA, are confident that it is a natural comet, and an extraordinary one. A single voice at Harvard urges us to keep questioning. Both agree it is worth every second of our attention. The visitor is already on its way out, back into the dark that it came from. But the questions it raised will stay with us far longer than it did. For a brief moment, the deep past reached into our present, and we were awake to see it. If this gave you a new way to look up at the night sky, take a moment to subscribe. I follow these discoveries closely, and I will be here for the next one. Until then, keep looking up.